Now, I won't be doing this in every walkthrough. There's no need to always be manually parsing these file systems. Obviously, computers do that just fine. But after spending all that time reading all the dry information in that long file system forensic analysis textbook, I thought maybe I would just give you a rundown and save you the trouble. That way, you'll still know the basics, but you don't have to sort through it all. So there's a few terms you've already heard and some new ones related to the FAT file system. There are sectors, which are groups of 512 bytes, and in FTK Imager you can see this dotted line denotes the beginning of a sector. So there's also clusters. In this case, a cluster is just 2 sectors. The boot sector will tell you how many sectors there are in a cluster on your particular disk, but that's going to be pretty typical. So if a sector is 512 bytes, like I said earlier, a cluster is 1024 bytes. That is twice the number of bytes. I've got a link to, well, several links to pages that tell you in more detail about the FAT file system. None of them are going to be the equivalent of reading that book, obviously, but they will give you a quicker rundown and a little bit more information than I'm going to give you here. Now, as far as sections of this, it begins with the boot sector, which is like that MBR we saw earlier, master boot record. You can see it's got this invalid partition error here. It doesn't mean an error occurred, that's just stored there for the operating system to display if something goes wrong. But that's an easy way to tell where a boot sector is. Then you've got the FAT, which immediately follows the boot sector. Then, well, the FAT tells you the allocation status of all of the sectors within the disk that you're looking at. And that's about all it does, so we won't really be working with the FAT in this case. What we will want is the root directory, which comes directly after the FAT. Now, the FAT's pretty large, so it's going to be a little bit tricky to find that root directory, but obviously that's what we were looking at earlier up here. FTK parsed it for us, and you can see it contains all of the files, and if there were any other allocated files that had been put in place by the FAT file system on this disk, they would either be within a subdirectory of this root directory or directly in it, like the ones you see here. It is just the base level at which files are stored. The next section of the disk is the data area, and that's where the files are actually. The root directory is just information about the files and where to find them. Only other concept you need to know is big endian and little endian, and it's like I said earlier, the first value is either the big one or the second. What I didn't explain at the time is it's not a mirror image. So let's say that this value here, 31, well actually, that's already a mirror of itself. That's a bad example. Let's go with this one, 310200. So if this was one value, as denoted by one of our tables that told us that this is where a value is located, then if it was big endian and we wanted it in little endian, we'd flip it, but it's not an exact mirror image. This 3-1 does not become 1-3. What it is that the bytes are switched around, so it would become 000231. Just in case that's not clear to anybody, it always catches me up a little bit trying to flip those around, because little endian is really the more common one. But there's a fair amount of big endian stuff on here. So in order to find the files, we will need to find the root directory, and that's what this next section is going to be about. We're going to begin with the boot sector. So if you look at the reference material I've provided, you will see the offsets of values for the boot sector. You'll see the OEM name in ASCII is at offset 3 to 10, bytes per sector is 11 to 12, and so on. So, We've got the bytes per sector, which is an important value to know. We already know that it's 512, so let's just check and make sure we're actually in the right spot here. We start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's 11 and 12. We've got our hex values. We're going to copy them, and we will just go to something that will convert hex for us. So you can see the number we get here in decimal, 8188. That is not one of the allowed values for the bytes per sector. Those are 512, 1024, 2048, 4096. So maybe this is Big Indian, and this would assume that it's in Little Indian because that's much more common. So maybe we put FC at the beginning here, make it Little Indian. Okay, well, it keeps messing up, but here's the spoilers. It's still not one of the allowed values, and it's certainly not 512. And the reason is this. I actually messed up and interchangeably used the terms MBR, which is master boot record, and boot sector. They are not the same thing. An MBR is found at the beginning of the disk, regardless. It tells the operating system how to begin booting. The boot record is actually found at the first partition. So if we look at this unpartitioned space in FDK, we get the MBR here, and that's actually the beginning of the disk. If we were to come here to the beginning of the first partition, right here, this is actually our boot record. So let's say we need to find that. We're in the image here. We want to do a search. There are several signatures in here that we could use based on the values that we know are in a boot sector. But the easiest one, if you look at the value that is contained in byte offset 54 to 61, you'll see that it actually has in ASCII the file system type. FAT, FAT12, FAT16, 32, whatever it is you have. So in this case, we know that we have FAT16 based on the scenario, so we can actually just do an ANSI search for FAT16. And what do you know? We found it. There is our boot sector, and we've got the offset for the disk itself. Now we can check quickly the bytes per sector to make sure. This is 8, 9, 10, 11, and 12, 0, 0, and 0, 2. Well, that is pretty obviously just the number 2, whether it's decimal or hexadecimal. But, like I said, might be Big Indian. A fair amount of the time, it turns out it is. So that would make it 0200. And that, whether or not this actually works this time, and it doesn't, that is 512 in decimal. So now we know we found our boot sector. We know that there are actually 512 bytes per sector. But what we're going to want to look at next... Oh, actually, let me back up real quick because I forgot. There are actually 2 boot sectors in here, so another trick with this. We've found the first boot sector, which, if you take a look at all the partitions, this actually comes before the first partition. So I honestly am not sure why it's here, but if you search again, we will find the second boot sector here, which is within the partition, and this is the one that will actually lead us to the root. And if you followed the same logic with that first one, you would basically just end up nowhere and confused like I was at first. So you may have noticed among our many different offset values for the boot sector that there's something that actually tells you how many FATs there are. You would think that there's just one, but when you think about it, it's constantly being written to as you work with files, right? So having a backup just in case it gets corrupted, maybe you lose power while writing a file, actually makes a lot of sense. So the typical number for that is to have 2 FATs. We can look at the offset value to it, and that is 16. So we will come back to our boot sector here, and this would be offset number 16, and the number is 2. We have 2 fats, just as we might expect. So now we need to know the size of each fat if we want to find our root directory that starts after those 2. In this case, we look at offset 22 and 23, so this is 16, 17, 18, 19, 20, 21, sorry, it's 22 and 23 right here, FA00. Now, this is actually in Big Indian again, so we want to convert 00FA, which is just the same as FA. So that number is 250. We have 250 sectors in each fat. We know each sector is 512 bytes, so we can multiply those together. 250 times 512 gets us 128,000 bytes per fat. But we had 2 fats, so we multiply that by 2. We've got 256,000. Problem is that is the offset from the fats. That's how big those are. So we need the offset from the start of the disk. That's what we're working with here. Which means we want to know where the boot sector starts and where it ends. So there is a signature for the boot sector that shows you exactly where it ends, and it is AA55 index, or in this case 55AA, because it is Big Indian once again. So that tells us, as you might have expected if you were thinking a little bit faster than I was when I did this, a boot sector is 1 sector. It's 512 bytes. So we add that onto the size of our fats that we have here, and we know that from the start of the boot sector we have 256,512 bytes. From there is where the root should start. We could have also used the offset from here, but at the time I didn't know that right here at the end of this sector is where the fats begin. So let's just play along and say that 7E0000 is where we're going to get our offset from. So we need to know the value of that in decimal, 7E0000, and that will get us 8257536. So we can copy that number. That is our starting point for this offset, and we will add it to what we're looking for here. And there we go, 8514048. Copy that, go back to FDK. You can right click and go to offset. You can also use Control G if you want. And there it is in decimal, not in hex in this case, because we use decimal to calculate it from the beginning of the file, because that's how we figured it out. And look, we could have actually also gone with current position and not needed some of those calculations if we just clicked right at the beginning of the boot sector here. But that's okay, it wasn't that hard to just convert 70 or there into it. And it sure looks like it worked. We have all these things with .txt, and look, that looks familiar. 7-1, that is the files that we saw in the root earlier when we had FTK parse it for us. So we've done well there.